Flair Furniture Company, wherein we have our linear programming model written as maximize profit, and that is equals to 7T, $7 of table, plus $5 per unit of chair. Subject to constraint number 1, 3T plus 4C is less than or equal to 2,400 hours of carpentry. Constraint number 2, 2T plus 1C is less than or equal to 1,000 hours of painting. And then the requirements of marketing are the tables should be greater than or equal to 100 and the chairs should be less than or equal to 40. And then our non-negativity constraint, where table and chair should be greater than or equal to 0. Okay, so we have set up our table here, our linear programming model in Excel. So like this one. So again, we have our left-hand side, our right-hand side, and our slack variable. Right, and then our these are our coefficients for our profit and equation and for our constraints equations. Again, I used here some product. Okay, you see there are also dollar signs in here. So all of them. We have here the constraint. So this time we're going to solve for our table and chairs. That will maximize our profit. Okay, not just any number of units to produce, but those numbers that will maximize our profit. So we use solver. Let's use solver. Okay, set our objective. Our objective is to maximize our profit here. So this is our profit cell. Okay, profit here, profit. And then our goal is to maximize. So we choose max by changing variable cells, which are tables and chairs here. And then we add the constraint. Okay, so as I said, we can do it one by one, but since we have already here two constraints that are very subsequent, one for carpentry and painting, and both of them have less than or equal to inequality function. So let's just put them all together, both of them. The inequality function here is correct. The constraint on the right hand side is this one. Okay, and then add, because we have another constraint to add. So that is for minimum tables greater than or equal to. So we change it to greater than or equal to, and then our right hand side constraint is 100 here. We have to add another one for the maximum chairs, less than or equal to. Okay, and right hand side is 450. Then we click OK since we're done. Okay, so that's it. We have added our constraints here. This one here with longer equation, this already covers two constraints, and then we have the two single constraints. So we make sure this one is checked, and our solving method is simplex LP. Once we're done with that, we solve. Okay, so it says solver found a solution. All constraints and optimality conditions are satisfied. Right? So there you have it. All constraints are satisfied. So if any of these are not satisfied, it will also appear here. Okay, that let's say solver did not find any solution, and that constraints, not all constraints are satisfied. So that means you have to rerun your review your constraints, your data, your input, and rerun your solver. Okay, so of course we want to keep our solution. Click OK, and that's it. So we have 320 and 360. So if we compare that, let's just use this graph. Okay, so our optimal solution is okay, it's not seen in here, but if you go back to our previous discussion before, so the answer is 320 and 360. Okay, and where our total profit will be at 4,440. Okay, and this will be our total hours for carpentry, total hours for painting, and also the number of tables that we will produce. Okay, so this is for tables, minimum number of tables, and the maximum chairs is this one, 360. So that's it. You see here for carpentry and painting, we don't have any slack variable, meaning all of our resources have been used. All of the 2,400 hours and 1,000 hours, all of them have been used in producing our maximized variables or tables and chairs to get the maximized profit. But the requirement of marketing, so one of the requirement of marketing is this one. When it comes to table, it should be less than, at least 100. Okay, so now it's 320, so meaning we have here the slack variable is negative 220, so meaning there's more. Okay, we have produced more. This is not about resources, so we cannot say that we cannot use the term resources because we're just talking about the minimum. Okay, and for the chairs, the maximum is 450, but according to our solver, okay, given our solution for tables and chairs, so what we should only produce is only 360, okay, to get the maximized profit. So this is it. Okay, so that is option number 1 using solver. Option number 2 is using the matrix multiplication. Okay, so we go for x1 and x2. So let me just format that so that we can see. Again, highlight both of the cells and then equals m mult, then m inverse, and then our first point. Okay, so again, we are going to look, so we cannot highlight all of this, we only have to choose 2, and then later on we choose another set of constraints, another partner, so partners of 2, closing parentheses, comma, our right hand side, close parentheses. Okay, and then shift, control, enter. Okay, so we see there 320 and 360. So this is our first point. Okay, let's say it's point number 1. Point 1. Okay, so for our point 2, so let's do the same. So this time let's choose carpentry and this one. Okay. Okay. So actually it will be a different number. So it's not. Okay, let's just try it. So m mult and then m inverse. Sorry, m inverse. Oh, I'm sorry. I don't think we can do this because let's just try this painting and tables first. All right, because they have to be together. So painting and tables first, minimum tables. And then this one. Okay, so that's our second point. Our third point will be oops, what's that? Let's have minimum and maximum chairs. M mult, M inverse, and then right hand side, Control Shift Enter. That's our third point. So for our point 4, let's have carpentry and minimum tables, but we have to put them together. Okay, so point 4. Okay, so let's have first the this is for carpentry and the minimum tables. Let's just first get this data here, copy them, because we cannot run the M matrix multiply if they're not together. So this will be our x1 again, highlight M mult, M inverse. So I forgot the constraints, sorry. Let's add the right hand side. Okay. Let's just put it here. Okay, 2, 4, and 100. Okay, again. M mult, M inverse, and then our array, and then this one. Okay, and then Control Shift Enter. So that's our fourth point. And then our next point will be let's just copy now the format. So that will be carpentry and maximum chairs. Max chairs. Carpentry, maximum chairs. So let's copy that. And then we have this and this. And we have it here. So we can compute our. So this is the thing if we have a lot of variables. Okay, and now we go to painting combination. Okay, painting and maximum chairs. So that will be our 0.5. So 0.5 is painting and maximum chairs. Copy. So that's the thing. So we have to put them together first. Okay, let's run again the formula. M inverse. And this one. Alright, so these points should be the points that we should see when we have the graph later on. Okay, so 0.1, 320, and 360. So if we actually look in here, so that is somewhere here, right? 320 and 360. So we solve our profit. So this is the manual way of doing it. Okay, so let's try to use transpose this time. Okay, so for example, some product. So let's transpose our point 1. Our point 1 is am I doing it right? It's 7, this one. Okay? So we're looking for the profit. So profit per unit. And then our second multiplier is this 2. Okay? Oops, I'm sorry. What is the problem? Is it this transpose? Transpose doesn't really work for me. Why? Let's try this one. First array, and then our second array is I want to transpose. The reason why we need to transpose is because this one is horizontal, the other one is vertical. Ay, ayaw. Sige, let's do it manually. Because ayaw niya. X1 times profit per unit plus this 2 plus the, times this. Sorry, that should be multiplied. Okay. And we have 4,040. Okay, our profit for point 1. So our point 2, okay, the same. We actually just want to copy the formula, but again, it refers, we have common. Again, we have common coefficients or we have common variables, which is the profit per unit. So why don't we just put $sign to our C, this is C4 and D4. Okay? So we don't have to type again all the formula all over again. Control C, let me copy this to Control V. Okay? If we check, that is this one, 100 times 7, 800 times 5. See? Okay, copy the formula. And then another one for this. And then another one for this. And for 0.5. Okay. I see something. Okay, so if you see here, okay, this one is 4,040. 0.2 is 4,700. Higher. What will happen when our maximized, our optimal solution shows 320 and 360? So 0.1 should be the correct one. So let's find out later on, okay? But for now, okay, let's have 0.2, which will give us profit of 4,700. 0.3 will give us profit of 2,950. 0.4 will give us 3,325 profit. 0.4. Okay, so this should be 0.5. Sorry about it. Okay, so that's 3,650, and our 0.6 will show 4,175 profit. So let's see that later on. Why is it like that when we graph? So let's first put it in the graph. Okay, so in order to plot all this into a graph, so let's assign the values for x and 1, x1 and x2. For now, let me just move it. Let me just move it somewhere here so that we can make use of our columns for tables and chairs. Okay, so for our constraint for carpentry, so what if this one is 0 and x2 is 0? That is 4 divided by 4. And for this one is 4 divided by 3. Okay, if we want to recheck, let me just move it let me just move it again. So we have a checker. Okay, so if we use sum product times this we should get y. Okay, we're talking about constraints, so this one, not profit. Constraint for carpentry, right? That's, there it is, 2,400, okay? And we want the same here for our formula for the second one, should give us also 2,400. Okay, so this will be our points for carpentry. Now for painting, so what if this one is 0? What if the other one is 0? 1,000 divided by 1, and this one is 1,000 divided by 2. Okay, let's run this, but of course we want to fix this first. We get 1,000, and both of them should have 1,000 each. Okay, now let's go to the minimum tables. Let me just copy that. For the minimum tables, for our points, so 100 divided by 0, that is 0. Let's just put 0 since it doesn't want to read that. And this one is 100 divided by 1. But later on, we're gonna make some few changes here. Okay, when we actually do it in the graph, when we plot it into the graph later, we're gonna make some changes here because we will not be able to get the line that we really would like to see if we keep it like this. So for now, let's just keep it like that. Okay, and for our minimum chairs, that is, this one is 0, and this one is 0. So 450 divided by 1, that should be 450. This one will be 450 divided by 0. So let's just type 0 here. Okay, and let's correct our formula. Okay, so now we are ready to plot all this into the graph. Okay, let me just make it a little bit smaller this time so we can have the graph on the other side. Okay, let's put it on the graph. First point, insert, scatter, okay, with straight line and markers. So with this, we would like to make sure that our x-axis is 0 and 800. So we're going to switch the row and column again. Okay, like this one. And then we want to add legend. Let's just position it. Sorry. Oh, no. Right, format legend, the bottom. Okay, and we want to edit our series name. This one will be carpentry. Okay, let's remove the title. Sorry. Okay, let's remove the title. Actually, don't need that. And then we add the painting line or constraint. Painting x values is this one. Our y values will be this. Sorry, this. And we have it there, painting. Then let's add another one for table. So before that, let me just click OK. Now, as I was saying for here, okay, we're going to change something. So if we actually just add, for example, minimum tables, and then, for example, okay, let's continue like this. And then this one is like here. Okay, so look at this. Okay, our line just remain into the x-axis. So since we're talking about minimum tables, and our tables is our um, sorry, is our x-axis. So in that case, okay, we say here that our minimum is 100. Okay, this is our x-axis. So the minimum is 100. So our line should actually just be a straight line upwards or vertical. So that is what we should see, because we are being given a minimum constraint. Okay, so everything that we're going to produce here, for now, this is our feasible area. But if we add the minimum requirement, so, our feasible area will just be on this at the center. So we have to set the straight line here. So to do that, so we have to have our, we have to change this to 100. If we do that, it's 100 here. Am I doing it correctly? Okay. Again. 0. No. 100 here. We set the 100 here. Okay. But you see here, it's just up to this point. So we would like to have the graph all the way there. Okay. So to do that, let's choose, let's say 1000 here. Okay, so it will somehow go up to this level. Okay, there. So right, so we put this to 100 and 100. Okay, so that everything will keep intact into this point at x-axis. And then for our y-axis, we want to bring our line all the way up. Okay, let's say up to 1000 or whatever point we want, so that we can just see the line in here. Okay, so the same with the maximum chairs. So if we actually put it into the graph, select data, add maximum chairs, our x value will be this, and our y value will be this. Sorry, I forgot to delete. Okay, it's okay there. But you see again, it's just in here at this point. So let's make a few modifications. Let's put 450 here. Let's just copy so it will remain on the y-axis. And then we want to bring this all the way there horizontally. Okay, so let's just copy up to this 800 points. So that will be 800 in here. Okay, so there we have it. So we have said this is maximum, this is minimum. Okay, so let's just see if our graph is proportional. So let's make few changes. Yan, so that we can interpret the graph better. That's it. And if you compare this with the graph in here, so they should be the same, right? So we should see the same line in here. So now, we say that this is our feasible area, right? So we can just shade it. Okay, so this is just one problem. Still, we're still taking some time. No. Sorry about that. Insert. Okay, I won't make it really exact. Okay, so that's our feasible area. Since we're talking about the constraints are within this bounds, so that's why this is our feasible area. Now, where do we use these points? Okay, so as you see here, we actually have a lot of corner points wherein These are our choices for our maximized profit. Okay, so our first point is for where x1 is 320 and x2 is 360. So where is that? So somewhere here. So x1 is 320. So it's possibly this one, and x2 is this one. So this is our first corner point. Let's add a text there. Let's say, let's point it with, I put 1. Let's just change it to A, B, C, D. Okay, point A where x1 let's just use the profit. It's 4,040. So we should know that x1 is this point. Okay, so let's just add another arrow. Let's just add arrow later on. And then for point B, it is this where x1 is 100 and x2 is 800. So this is this point. Okay. Actually, you can see it there. You see, series minimum tables point 100, 100, 0. For this one, okay, if you just put the pointer there, it's hard because of the shape. Okay, we can still see there 500. Sorry, it just refers to the painting. Okay, so to make our lives easier, so let's just add some labels. Okay, so this is our point 2 or point B. Okay, where our profit is equals to 4,700. And then our point C is our this let's insert again another text, and that is where x1 is 100 and x2 is 400. So this is this one, this point, right? Let me just put it somewhere here. So our point C is equals to 2,950. Oh no. Okay. And then our point 4 or point D is 105.25. This 105.25. So this one. Okay, this one. So that is our point D, or point number 4, which is equals to 3,325. Okay, and then we have another point 5, which is 204.50. So that is 204.50. Okay, this is actually this point. So point E or point 5, that is equals to profit of 3,650. 3,650. And our last point is point 6 or point F, where it is 275,450. So 275 and what's the other one? 450. Okay, it's overlapping. That is equals to 4,175. 4,175. So which is this point? So our point E is this one. I hope you're seeing my cursor. Okay, this is our point E, but our point F is this one. Okay, the one that is intersecting the maximum chairs constraint line and the what is the orange? The painting hours. Okay, so if you will notice, so actually there are more points because we still have this, right? This one, this one. Yan. But if only with this, we can notice that the other points may have or may give us larger amount of profit. However, they are already beyond our feasible region. You see that? This one, point B, okay? It gives us 4,700, but it is already beyond our feasible region. So if we actually use this for decision purposes, then we will have to sacrifice some resources, or we will have to compromise. Okay? So that's why, since in this graph, it shows that it's not within our feasible region, then this, although this will give us larger amount of profit, but it will not give us the maximized profit, because there will be other costs that will be affected. Okay? The same with the others. Okay? So all the other points, okay, that give us larger amount of profit, they are beyond our feasible region area. So in that case, they're not really the solution. Those points will not give us the maximized profit because of what will be sacrificed. And the same with those that give us lower amount. So they may be within the feasible area, like point C, it's within the feasible region, but it gives us lower amount of profit. So what is now the correct answer, which will give us the point, okay, where we will get maximized profit? So that is this point. Where is that? Our point A. So this one, okay, where our table will be at 320 and our chairs will be produced at 360. Okay, so that's how we interpret our graph. Okay, so that actually concludes this problem number 2 for Flare Furniture. And then, as I said, we're going to discuss the sensitivity report, because if you actually go back to the solver, okay, there are reports available. Okay, so these are the reports available. So it gives you the answer. It gives you the sensitivity report. So when we say sensitivity, what happens, how will the profit change, how will the objective change if some of the factors or variables are changed, or let's say some of the coefficients in the constraints are changed. So how will everything change? Okay, and then the limit. So we're just going to discuss this in our next lecture. So I'm going to give another video for this, okay, so that we can save some time. And that should